Great. Um, Let me share my screen here. All right, can you see that?
Yeah.
Okay, great. Well, thank you guys so much for letting me speak. I appreciate the invite from Leo. I'm excited to get to talk to you about Go for Data Science today. Hopefully, get to attend the meetup someday. I would love to be there. Yeah, today I'm going to talk a little bit about Go and in the context of data science. The first bit of my talk is going to be a little bit of a repeat from my GopherCon talk. So sorry if you've already seen that. But then the second part, the demo will be a little bit different. So stay tuned for that. And I'll try to answer questions afterwards. I think there's a question and answer in Hangouts, which I'll try to look at after I kind of switch back to the other screen. But also, I'm on Gopher Slack at the Whitenack, and also the same on Twitter. So feel free to post questions there. There's a data science channel in Gopher Slack, so happy to answer questions there as well. Okay, so today I'm just going to give you a little bit of an intro about my background and how I got into doing Go for data science, and then what data science is actually, and some struggles related to how people are doing data science in industry right now. And then we're actually going to dive in a little bit and do a few demos. And then I'm going to give you a few different resources that you can visit after the talk as well, to kind of try things out and maybe contribute as well to some projects. So first, let me give you a little bit of an intro about why I'm talking about Go for data science. I actually started out my background in physics. I did my PhD in computational physics. Back then, I was primarily working in Fortran. I developed a framework for calculating properties of atoms and molecules. And then after doing academic research for a while, I began to hear a little bit about this field called data science, which seemed pretty exciting. It also seemed kind of related to the traditional research that I had done in the past, and where people were utilizing some of the techniques that I had used in physics to solve some interesting problems in industry. So motivated by that, I joined a startup called Telnix as their first data scientist. They do voice over IP stuff. And I worked with them for quite a while, developed a data science team there. I think there's about 5 or 6 there now. They continue to develop some great data-driven services and monitoring systems and visualizations and a lot of different things. But while I was there, I basically worked in Python when I started because one, it seemed pretty widely used in the data science context, but also there were a lot of engineers already there at Telnix working in Python. But by the time I left Telnix, I was actually primarily working in Go and using Go for data science. So why is that? Why did I switch from Python to Go for data science? And it really comes down to a series of struggles which I think are common amongst data scientists, and that were solved by some of what Go offers. So I'm going to go through those in a little bit, but before we do that, let's just come to a common understanding about what data science is. So you might have seen what I like to call hashtag data science on Twitter and blog posts and news articles. This is basically what I like to think of, what you see publicly about data science teams and what they're doing. And this might be, for example, like the team at Google recently that trained a neural network to play the board game of Go and beat the grandmaster at that game, which is extremely impressive. And I always find these things, incredible and just extraordinary. But really, day to day, data scientists aren't solving a lot of problems related to board games. They're mostly doing these three things. And I think that data science in general is trying to develop insights from raw data. And these are the three main activities that I feel like are involved in that process. In order to transform raw data into insights, first you need to be able to get data, you need to be able to organize it and clean it, you need to be able to parse it and extract things out of it. And then you also need to be able to do some arithmetic. And this arithmetic might be as complicated as convolutional neural network, playing a board game, but in a lot of cases, it might be just as simple as doing aggregations, calculating sums, finding out standard deviations, and looking at distributions. So it could be any range of that arithmetic, but generally these are the three activities that I would say are pretty much always involved in that transformation of raw data into insights that a business can use to make decisions. Okay, so I mentioned that in doing this sort of work and in working in Python, I had a series of struggles that really motivated me to start using Go. And I feel like that Go very much overcame those struggles for me, and which is why I continue to do data science in Go. So let me describe what those were. Basically, they center around integrity. And the fact is that when I was doing data science with Python, I felt like I couldn't maintain the integrity of the applications that I was developing. In a first respect, I felt like when working with Python, I couldn't really always reproduce what I was doing. I felt like I was doing some cool data science, complicated data science thing, and then my head would just be left spinning because it would behave like I expected for quite a while, and then all of a sudden it would start behaving differently, which is not good. But then when I would look at the logs, look at my metrics, and try to figure out what was going on, it seemed like nothing was behaving differently. It seemed like there was no errors, nothing was happening. Let me illustrate this with a simple example. Let's say that we have this huge CSV file with 3 rows and one column of integer values and one column of string values. Well, without too much trouble, I can write a little bit of Python to parse that CSV file and print out the maximum value in the integer column. And also without too much trouble, I can write a little bit of Go code that will open the file, read the CSV records in, and then loop over the records and print out the maximum integer value. And of course, to do this, I need to convert those string values coming in into integers and handle that error. So if I run both of these examples, not too surprisingly, they both get the correct answer. They both print out 3. But what's interesting is, let's say something happens to my data, something happened in my pipeline, and I just remove one of those integer values. What's going to happen? Well, in the Go case, being a room full of Go programmers, you might expect that we'll get an error thrown because we're parsing those values into integer values, and the empty string is not the zero value of an integer even, or can't be parsed into an integer, so we're going to get an error. But what's kind of surprising is what happens in the Python case. So in the Python case, I run my example, and I still get an answer. I don't get any error, and actually I get a float. So now I get the value of 2, and somehow my value has been turned into a float. And I'm still not totally sure why this happens. And really, I'm not saying that there isn't a way around this, but I'm saying my point is basically that there's about 1 million of these little gotchas if you're working in Python or a dynamically typed language, where if you're doing this sort of data parsing, data gathering, you can really shoot yourself in the foot in quite a few different areas. Whereas in Go, we maintain our integrity, we get a reasonable error out, and we can, if we wanted to handle that differently, or maybe fill it with a 0 value or whatever we want to do, but we have control over it and we maintain integrity. Also, a second place where integrity is hard to maintain in doing data science with Python or other languages such as R is in deployment. I always felt like when I was deploying data science applications written in Python that I basically sat down with my DevOps team around the war table, and we had to kind of strategize about how to get all these different pieces of the Python ecosystem into place such that our application would behave as expected. And this was incredibly complicated. You might have a Docker file that looks something like this. Hopefully, all of you can read that. Basically, the moral of the story is, if it's this complicated, you probably are going to have some trouble maintaining integrity and deploying things in a way that is reproducible. Whereas with Go, of course, we can just compile to a static binary. Our dependencies are vendored in, which I think we're going to talk about a little bit more in the next talk. But I found this incredibly refreshing. Now my Docker files, look something like this, and I can really have some confidence about how that static binary is going to behave in production, which was a huge benefit for me. And not only that, so now we've seen that we can maintain integrity in terms of reproducibility and deployment, but of course we also get the advantages of being able to have the scalability and portability that Go provides. So all of these things kind of led me to the place where I'm at now, and I think are great motivators for data scientists to work in Go. All right, so let's move on to the second part of the talk and actually go through a few demos and hopefully illustrate to you guys some packages that you can start to use to do data-related work in Go, and hopefully motivate that not only does Go provide us with integrity, but it also, the ecosystem in Go already has quite a few different really great packages and tools that will allow us to do data science. So let's put these guys to work. First, we need some data to work with, and since this is a Go meetup and we're all interested in Go, I decided to gather some data about Go itself. So what we're going to do is we're going to scrape some data off of GitHub about Go projects on GitHub. And to do this, we can use Google's Go GitHub package. So let's look at that here, and I can post the link to this code afterwards as well. I'll give it to Leo. But here I have this example. Here you can see I'm importing that Go GitHub package, and I'm also going to use Dave Cheney's errors package to handle my errors. So what I'm going to do is define a start date as January 1st, 2013, and then I'm going to query all GitHub repositories written in Go from that start date until now. And the meat of that is contained here in this query from start time. I just create a new GitHub client. I have to loop over time periods because I need to stay within GitHub's rate limiting constraints for their API. And I also want to get all the results. By default, GitHub will only return, I think, 10,000. So I need to make sure I stay below that. And in the client query, basically, I'm going to loop over pages in the results. And then I'm going to pull out the things that I'm interested in. So name, updated at, created at, date, time, forks, issues, stars, and size. Here, I'm just printing those out to standard out, but you could redirect to a CSV. And since we have to, stay within GitHub's rate limiting, I've actually already run this prior to the demo. I ran this a little while ago and got all the data out, and that looks something like this. So you can see I've got a bunch of repo names. I've got created at, updated at, date times, and I've got forks, issues, stars, and size of the different repos. Awesome. So we have that data now. But what about these other things that are often done in data science? So I mentioned arithmetic, and kind of within that, we can think of visualization and prediction. A lot of my Python data scientist friends might offer some help right now because they're not sure Go can handle this. But I'm very happy to say that we can definitely handle this. And this is where I really want to show you guys some great techniques and tools out there that are available for these sorts of things that you can utilize in your own projects. The first is GoNum. So the GoNum organization has just a ton of great numerical and statistical packages that will allow you to do just a host of different things. So you can see here I've listed out some. I think there's even more now, but they have a Go native implementation of LayPack and BLAST. They have numerical integration, statistics, graph-based algorithms, matrices, linear algebra, plotting. And so this is really just a great organization of packages and something that I would highly recommend taking a look at. And we'll use this here in a second in our demo. Also, in terms of prediction, there's also a lot of great things out there for you to be able to do machine learning in Go. So I'm going to use this top one today, which is a great package for doing regression. But there's also things like GoLearn. There's this Freeling package, which will allow you to do a lot of NLP stuff, natural language processing. There's a ton of these, which I've listed here in this link. But even if you didn't want a Go package, pretty soon there's going to be a Go API for TensorFlow and SDK for Beam, which means basically that you could do any sort of machine learning you want right from Go, either via a Go package or via API or SDK to these other frameworks. So that's really exciting. I think it's a great time to start playing around with prediction and machine learning in Go. And so now what I'm going to do is I'm going to do a demo for you. But in doing my demo of these packages, I'm going to utilize this side project of mine called Gopher Notes. And this is the hope with this package is that we can provide a way for people to do kind of exploratory data analysis and interactive programming with Go. That's something that data scientists like to do a lot because once we have our data, we want to figure out what's in the data, what does it look like, what are there any issues with it, and maybe format it and organize it in a sort of interactive way. So for those of you that aren't familiar, Jupyter is a framework that allows you to do interactive programming and kind of visualization and reporting within your browser. So this actually is a framework that includes kernels for a lot of different languages. But the main thing that people utilize Jupyter for is these notebooks. So you can create a notebook and then include live code cells in that notebook, along with Markdown, along with pictures, visualizations, equations, and a lot of different things. So it's a great way for both kind of recording and reporting what you're doing, but also doing it in an interactive way where you can kind of explore your data and figure out what's going on. And I've been working on this this Go kernel for Jupyter. So how this works is Jupyter itself is a web server, is all it is, that serves these notebooks. And when you evaluate something in these notebooks, then it sends that off to a kernel that's sitting in the background that evaluates it and sends the result back. So that's what this this kernel is. And to show you an example of what this looks like, I have a few different examples here that you can look through. But if we look at one of these, and another nice thing is that these are rendered in GitHub very nicely. So they're nice for this. But as you can see here, you can kind of mix pictures and Markdown explanation along with live code, snippets of live code that you can evaluate right within the notebook. So let me kind of give you an example of that. Here, you can see in this repo that I have, that I'll post the link to, I have a notebook that I'm going to use for the demo here. And I have the data that we generated before. And if I just run Jupyter Notebook, okay, it's going to start up this web server. And you can see that my browser flickered over here. So if I go back, it's spawned a tab in my browser, and now I can see this directory structure in my browser, and I can do a few things from this kind of home panel of Jupyter. I can open up this demo notebook, which I'll do here in a second, or I can create a new text file folder, terminal, or a new notebook. So you can see here I could create a Python notebook, or I could create a Go notebook. If I create a Go notebook, it opens up another tab with this example notebook. And like I said, this is, I don't know if any of you have used Mathematica before, but it's a similar idea where here we have cells, and I can type things into these cells and run them interactively. So that's a simple example, but I mean, we're using Go here. So you can type any Go code into these cells and evaluate it. And it's nice because it's interactive. So if I go up here, reassign that string, I can do it again, and it will reevaluate it with the new input. I can import packages, like whatever Go packages I'm interested in. See if that worked. Okay. So you can see this is all interactive without having to define a package main, or without having to manage compiling all this time, or deal with things like if I define this in a regular Go program, it would complain to me about how it was defined and not used. So you can do certain things like that in this notebook. But now let's close it this way. Okay, now let's go to this demo. So I've already created a demo for our time here, just to illustrate a few things to you. So as I mentioned, here's a little bit of information about Jupyter. But now let's kind of explore some of these tools that will allow us to do some really cool things in Go for data science. The first thing I'm going to do is interactively explore my GitHub data that I gathered with a package called Gota. And within that, there's a package called data frame, which will allow us to really easily kind of parse our data and explore it. So I'll import that, and then what I'm going to do is just read in my my CSV file, and I'm going to then create a data frame based on that CSV data that I read in. And this data frame object looks kind of like this. So there's a series of or the series of columns, each one being a series value, and that contains each of the columns in our CSV. And you can see that it automatically parsed out the header names for that CSV file, and it inferred the types that were in each of those columns. And of course, you can specify the type explicitly if you don't want it to infer. But now that we have this sort of data frame structure, we can do some pretty neat things. Let's say that we wanted to subset out only parts of our data frame. So for some reason, let's say that we wanted to see what the first row was and the last row in our data frame. Then we could use this subsetting functionality that will create a filtered data frame. And we can also use the FUMP print line, and that'll print it out in this kind of nice table form. So we can see that these were the first and last repos that I gathered when I gathered that data. We can also do really useful things. I think this is super useful in terms of exploring what we have. We can create filters on our data. So let's say that we want to learn what repos, Go repos we gathered had more than 30,000 stars. So let's select out our repo name column, and then we'll filter by the stars. Let's do that. Okay. And then we can print that out again. And now we can see, not too surprisingly, there's only one repo with more than 30,000 stars in GitHub, and that's Docker itself. So this, again, Gota is a great way to kind of do this exploratory analysis to figure out what data you have. But we can also do some processing. Let's say for the rest of our time, we just want to work with a data set that just has the repo name and the created at date. So again, we're going to read in our CSV. We're going to select out those columns, and then we can easily, with Gota, just save that out to a separate CSV file. We're going to call that process.csv. So we can run that. Now if we look at what we have here in my folder, we can see, okay, now we have this process.csv, and that just contains the repo name and the created date. Awesome. So next, let's do a little bit of visualization. So because we have the repo name and created date, let's try to visualize a time series of how many Go repositories were created every day from 2013 till about now, because I created this data set a little bit in the past. So I'm going to actually, one thing you can do that's kind of nice in Jupyter, you can basically restart your kernel, and that kind of cleared out my previous data or variables that I was using, because again, we're just using a subset of this data now, so we don't need to have that in memory. Okay, let's import just some things from standard library. And in order to create this time series, what we're going to do is we're going to create a map, and then we're going to loop over records in our data and count how many records were created every created daily from that day in 2013 till now. Okay, so that should have run. All right, let's see what that sorted counts look like. And here you can see on that first day, there were 14 created, second day, 13, third day, 15. And this is what this sorted counts looks like. And we can use GoNum plotting to quickly analyze and view what this looks like. So I'm going to import some of that plotting functionality from GoNum. I'm going to prepare some points for plotting, which just means creating this points value or the plotter.xy's value from GoNum. And then creating the plot is as simple as creating a new plot P and giving some labels and then adding those points to the plot and saving it out. So let's do that. It should process those, and then now if we look at this, we've created this PNG in our repo. Let's take a look at what that looks like. Here, okay, so we created this plot. You can see as we're all, I'm sure, happy, the number is going up over time, and it actually looks kind of linear. So this is a great sign as a data scientist. Maybe I want to fit a line to this. And what would be interesting is if we could predict how many repos would be created on some day in the future. So that's what I'm going to do next. I'm going to fit a line to this and then make a prediction. So if we go back here, I'm going to import that regression package that I mentioned. And I'm just going to fit a line to that time series that we have using this regression.regression value. And you can see that there's not, again, you don't have to go through a lot of struggle to do this. It's pretty quick. And then making a prediction is as easy as calling predict on that regression value. And we're going to predict how many Go repositories are going to be created today. So that runs that model. And then let's print out that prediction. So, all right, so hopefully 200, a little over 202 repositories will be created on GitHub today. And if you wanted to, you could see different information about how that model was trained by just looking at this regression object. You can see our R² value, our coefficients, and other things that are interesting. Okay, so hopefully I didn't go through that too fast. Like I said, I'll post the link to this notebook. You can try it out yourself. You can ask questions on Gophers Slack or in the Hangouts. And just to end things up, again, these slides will be online, but I'd like to encourage you to get on data science on Gophers Slack. There's also a couple other places that you can look for Go data science repos or resources. Here's some links to some other packages that I mentioned Goda, but some other ones that I didn't have time to go into that are useful. And thank you very much for your time. I'd really like to encourage you to try some of these things out. And if you're so inclined, contribute if you're able, and give feedback, open issues, and ask questions. So thank you very much.
Thank you, Daniel. Ребят, у вас же есть вопросы, да?
Let me see if I can get the screen sharing off here.
Yeah, one second, Daniel. Поскольку у нас тут с микрофоном, я попрошу подойти сюда и заодно разобьемся. So, Daniel, the first question is coming.
Hello, Daniel. Could you please tell us about just a little bit about how it works internally? Because I'm very interested how the compilation is done by this notebook kernel, and how intermediate values are kept in memory or how it's done.
Yeah, sure. So what happens is when the kernel is brought up, basically that Gopher notes creates a binary which is in your Go path, and then Jupyter sends a 0 and Q message to that kernel, and the 0 and Q message just includes the code that's in that cell. And what the Gopher notes does is it sets up a session file, and then it adds that code to that session file, doing some pre-processing on it and some fixing, and then it uses Go run to quickly run that that session file and send the output back. And then as you run more and more cells, you basically add more and more to that session file so that your variables are kept in memory each time you run it. And thankfully, because compile times are way down again in 1.7, this is basically interactive for all intents and purposes. I think there's another group, I think working under a Go interpreter repo in GitHub or organization that's working on actually a more robust Go interpreter, which should be able to be plugged into this kernel and maybe utilized when that's ready. But until then, it's basically using this idea of creating a session file and then running that and compiling it to get the output.
Okay, thank you. Another questions, guys? The second question is coming.
Hello. Thank you for cool story about data science. I have a question about Go native opportunities for asynchronous accounting. How to use this in data science? Do you understand me?
Yeah, so the question was about I heard Go native and using that in data science.
Yes, native Go routines, how to use.
Oh, okay. Yeah, sure. So the question, if I understand it right, and correct me if I'm wrong, is how we can exploit Go routines and concurrency in the context of data science. That is actually very useful because the more and more, so in previous times, data scientists most of the time read data from disk. Let's say they were using like Hadoop or something like that and reading from HDFS. But much more now that we have kind of modern architectures, which are really based around messaging queues and event-driven technologies, more and more data scientists are having to process data very quickly, let's say from Apache Kafka or some distributed queue or some messaging system. For example, let's say that we're receiving a bunch of requests to create suggestions for movies or books or something. Most likely in any modern architecture, those are coming in through a messaging queue, or they're coming in very quickly. And this is really something that Go has proven to be really great at because of its concurrency features. So we can utilize worker pools and concurrency to be able to scale the processing of those messages up and down as we have more and less load on that messaging queue. So I think data scientists will be happily surprised that they can not only do their modeling or data analysis, but they can also fit within this sort of modern architecture and be able to utilize concurrency to build something that will also scale very well and be able to process things quickly.
есть ребята, которые Data Science занимаются, которые, собственно, пришли к науке. Вот, я бэкэндер. Но когда я посмотрел код на питоне, вот, я понял, что там... Да, код на фортране, совершенно правильно. Код на фортране можно написать на любом языке. Если бы они то же самое сделали на код, то, ну, во-первых, органичнее, во-вторых, работало быстрее.
Ну а вообще, кроме вот той ошибки, которую я поймал, еще какие-то преимущества есть? Ну то есть там вопрос как бы обработки ошибок, я...
Нет, там достаточно примерно. Конечно, там то, что он питоном проводил, там все равно все имеет такие слишком реализации. Там тоже не понимаешь.
Hello, can you hear us?
I can, yeah. Can you hear me?
1 second.
Вы со всеми заметите.
Hello?
Yeah, can you hear me?
Yeah. We
Great.
had a witness problem. So, yes. I want to show you the... So,
Awesome. Looks like fun.
I think it's about 1 second. So, I think we have no questions. Thank you for letting talk. I will share the links with the guys, and maybe someone will help you with your project on GitHub.
Yeah, that sounds great. And like I said, I'm on Gophers Slack and Twitter, so look forward to chatting with you guys more. And thank you so much for letting me talk.
So, thank you again. See you. Bye.
А что он не будет?